go to the Science2 campus homepage, you're looking for the tasks to complete for U1L9. This is Unit 1, Lesson 9. You can find it under Assignments or on the campus homepage in the weekly calendar table. Just find today's date, which is the 5th of October. You'll see it there. First thing I wanted to do was review the homework and just make sure that everyone's getting that in. You had to draw the planets and color them in. Is everyone able to do that? Use your compass. Peeking at my grade book. Let's see. So seeing photo submissions from most of you. Sloan, Harrison, Clarence, Valen, Thomas, Joseph, and Summer. I still need to have submissions from you on Canvas. So if you did do the drawing and coloring, snap a photo and get those up when you can. And please make sure you've also submitted your photos of the notes for presentations 3 and 4. Again, about half of you have done that so far. So if you haven't done that, you'll notice that I excused you from your own presentations on Canvas. So that is not an assignment you're expected to do, but you should be submitting for everybody else. Any other questions or comments on the homework stuff? All right, I'm gonna endeavor to kind of stay on top of my grading more. I kind of let it build up this last weekend, and so I'll keep everybody up to date.
Hey,
yeah.
I submitted before class.
Okay, cool. I didn't hit update like right before class. So if you did, then it is hopefully in. So, all right. Then the next task was to see what you remember. Just like we had a little game with the sun. This time we've learned about inner and outer planets. So I've just got a short little 10-question quizzes, which is a similar program to Kahoot that we'll play to see what you remember about the inner and outer planets. Again, this isn't graded. This is just to see how we're feeling overall. So on my screen, which I just shared with you, you can see, go to joinmyquiz.com. The code you want to enter is 088373, and please use your name or something close to it. All right. We got 14 people in the class, so I'll wait until we get close to 14.
It's not letting me join.
Okay. Maybe just try hitting refresh a few times. And if not, then I think when I start the quiz, you'll still see the join code like in the lower part of the screen. I think it works very similar to Kahoot, but all right. Okay, let's get started. And again, you can keep joining, keep trying if you haven't been able to join yet. I think you still can join. Yeah, see, join code's at the top of the screen. The largest planet in our solar system is? All right, Nathan in the lead. It is indeed Jupiter. Which planet is closer to the sun than Earth? right, Jake in the lead now. Mercury is closer to the sun than Earth. The other one is Venus. The red planets. This is hopefully an easy one. Okay, Jake's still in the lead. Mars has that red coloration because there's so much iron in the soil and it's literally rusting. It's becoming oxidized. The planet with the most spectacular rings of any planet is. Nathan in the lead now. Saturn indeed has the most spectacular rings. However, all of the other planets have rings. Jupiter, Uranus, and Neptune. It's just Saturn are the most visible. What is the correct order of the planets from the sun? All right, Nathan, Jake still are top two. Very good. Most of you got it. It is indeed Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. I often think of the last three planets as spelling out sun. And then you just gotta, there's other anagrams you can use. Which one is a gas planet? You can think about distinctions of inner and outer. Jupiter is the only outer planet out of all those options. Earth, Mars, and Mercury are all inner planets, which are technically terrestrial. What is the hottest planet? All right, Nathan and Jake still in the lead. Harmony catching up. Only two of you got it. It is indeed Venus. Even though Mercury is technically closer, Venus has more carbon dioxide in its atmosphere and therefore has a hotter surface temperature. All right, Jake and Harmony in the lead. Very good. Most of you got it. It is Uranus. In fact, its rings are also technically sideways. Very unusual. Which two planets spin at roughly the same rate? As in their days. The day would be similar time period. Okay, Okay, Jake and Harmony holding the lead. Good. Again, most of you got it. It is Mars and Earth. Both have a rotation period of about 24-ish hours. Okay, last question. Well, the inner planets are solid, the outer planets are. Again, this is kind of a repeat question.
Yeah.
Yeah, way to go, Jake. Yes, outer planets are gaseous, hence they are called the gas giants. Okay, they already showed the leaderboard, but way to go, Jake in first place, Harmony and Clarence. Nicely done.
Yeah. I like that.
All right. Any questions or comments on the inner and outer planets? All right, the next step is to move on in our presentations. We're going to be hearing from Ryder and Thomas today about life in our solar system, and then Clarence and Joseph about the moon and eclipses. Ryder and Thomas, you feeling ready?
Yeah, I'll share my screen.
Okay, I'm going to make you a co-host.
Sounds good.
All right, everybody else, it is the usual expectations. There is an assignment where you're going to have to submit a photo of notes. So please grab a piece of paper or a notebook. You're going to want to title your notes Life in Our Solar System by Ryder and Thomas. So give us a moment too to write that down.
Can you see the slides?
Yep, coming through on my screen.
Okay. Thomas, you ready?
Yeah, I'm good.
Okay.
Some silence for a second.
All right. Life in Our Solar System, Mars, Enceladus, and Europa by Thomas and Ryder. All right, so starting off, I'm going to talk about the habitable, or what's also called the Goldilocks zone. So it's a zone around a star, which the star is the sun, where the temperature is just right, not too hot and not too cold, as like, hopefully you know the Goldilocks story, where it's like, I don't know, it's just like one porridge is hot, too hot, one's too cold, and then one's just right.
Happy medium.
And medium, there you go. And that zone is also called the habitable zone because it's where life can exist. And it's also where liquid water can exist on planet. Conditions for extraterrestrial life. So one condition that needs is temperature. So temperature influences if there will be liquid water, which is needed. So deserts is like an example on Earth that where you don't need a lot of water, but you need some source of liquid water for life. Life can grow and reproduce at temperatures as high as -15 degrees Celsius. I mean, as low as -15 degrees Celsius and as high as 122 degrees Celsius. The Earth and like the atmosphere needs to be carbon-based because to make biomolecules, we need elements such as carbon, nitrogen, hydrogen, and oxygen to combine.
And for those temperatures, if you go back real quick, like I know that seems like a huge fluctuation, like -15 up to 122, but that's actually a pretty stable environment for planet's surface compared to other planets. So yeah, that kind of gets at that Goldilocks stability idea. And yeah, carbon makes huge molecules, specifically sugars are really important, carbohydrates. So yeah.
Well, continuing on, yeah, stability is a big thing for conditions. You also like, besides like temperatures being stable, you need sufficient enough time for the life forms to develop and evolve. Living things, as we know, require energy. Sunlight can be a source of energy. Also needs chemical reactions that take place on or inside the planets, as well as tidal forces. As I talked about earlier, there needs to be a liquid medium, or it's extremely essential for liquid water to for in a habitable area. So liquid water helps molecules to move around and react with one another, which can create biomolecules as well.
In terms of your energy processes, really quick. So, do you know what's the process called that uses where biological organisms convert sunlight into?
Photosynthesis.
Yeah, that's photosynthesis. So, do you know what the chemical version's called?
Um, Not sure.
Anyone learn about this at all? Happens on the bottom of the ocean, where there is no light.
Oh,
Uh,
I do know it. It's
it's the same kind of name. It's just called chemosynthesis,
oh yeah.
where they're using
That's
heat and sulfur and that kind of thing to do a similar process. So, all right, nice.
All right, Thomas.
Okay, so the habitable planets and the Drake equation. So starting off with the Drake equation, it's an equation that finds out the number of habitable planets in our solar system in one equation. The Drake equation also is an equation that theorizes what can exist in our universe. So this equation to the right is like kind of like a little cheat sheet, and so all these functions on the right all equal n, and so n is the number of technological advanced civilizations in the Milky Way galaxy. And a habitable planet is a planet that can contain different life forms in its atmosphere. There's a theory that states that there's about 40 million planets in our universe that can sustain life. All right, and so this is realistic habitable planets in movies. For some examples, Star Wars, almost every movie, Corellia, Alderaan, and Mandalore are some examples. Avatar, Pandora, and Planet of the Apes, which is like a futuristic Earth / like different dimension.
Okay, so evidence of life on Mars? Question mark. So, well, some evidence is that so part of the Mars surface appears to have been produced by flowing water, meaning that like the way the rocky terrain is, it's like it appears to be like carved by flowing water at some point. Also, the Martian poles are still covered with water ice. So uh, this all implies that Mars used to be significantly warmer, which has to do with the temperature part of uh, like the planet being habitable. Also, bacteria-like fossils were discovered in a Martian meteorite, which created the speculation that Mars was not only once inhabitable, but was also or inhabited, but was also the source of life on Earth. But all of this further exploration is still required, so no one's 100% sure.
Yeah, that's one big theory is that Mars kind of seeded Earth. Yeah, I don't know. And that the photo, yeah, you can see there's a lot of like ice. There's definitely frozen stuff on the poles. My understanding actually is a lot of that is dry ice. It's frozen carbon dioxide, but there is some liquid water. There is some frozen like ice, some actual frozen water in there too. Mm-hmm.
Oh,
Okay, so this is Europa, and so it's one of Jupiter's moons. Contains an ocean beneath its icy surface, and it has all around has volcanic thermal vents similar to life deep beneath the ocean. So we don't really know what's underneath the surface of it. So it's kind of like a question that it's on our mind.
Yeah, I think there's been like reports of,
um,
I mean, what they think is like bioluminescence, I think, that's coming from below the ice, which would be indicative
mhm.
of some kind of living thing. But yeah, I don't know.
Yeah, yeah. They're thinking that like the volcanic thermal events, like the type of life that would be on your deep see life like down at the bottom where there's thermal vents under the ocean.
Mm-hmm.
And Enceladus, it's thought to have a global water ocean beneath its surfaces. And the ocean is salty, similar to Earth. And it also contains abundant organic, like I talked about. Biomolecules are really important for sugar, etc. And there's also thought on like the bottom of the global water ocean that there's hydrothermal vents. Okay, so this is the video. So this video, here.
It's going to show Mars. So it might be good to play it through your speakers if you have speakers, and then your microphone will pick up our sound.
Let's see.
Flying for the first day in the solar system. The small helicopter is named Ingenuity, and the idea is to prove that actually we can safely and efficiently fly craft on other planets. If mission is successful, future missions might heavily use aerial vehicles to assist with areas that are difficult to reach, or maybe to carry payloads between one asset and another asset on the surface. The first step is, of course, to prove that this technology is viable. The Mars atmosphere is rarefied, which means that getting lift that allows a flying machine to fly is much harder. But there are other challenges, like, for example, 80 minus 100 degrees Celsius. Mars, though, has some redeeming features. For example, on Mars, gravity is lower than the gravity we have on Earth, so that helps to some extent. The end result is a helicopter that is rather light, with blades that are quite large, about a meter, and that spin much faster than a typical helicopter you will have on Earth. I had the opportunity to give contribution, albeit quite small, to this mission. I was particularly working on the problem of landing site selection, how to pick the best between scientific interest and safety for the landing procedure. This is an extremely important mission for NASA. Perseverance is going to be a mission whose primary goal is to search for biosignatures on Mars, basically to search explicitly for life on Mars. This is extremely fascinating if actually other forms of, or at least biosignatures are found on Mars, might change the way we perceive ourselves as humans.
All right.
Nice.
Basically, most of the video was just talking about like how they're building it and what's going on, but the point that like I wanted to make with this video was about how this thing is gonna be searching for life on Mars once it makes it to Mars. So hopefully that will give us more insight about if life or if Mars was once habitable, inhabited, etc. Okay, thank you for listening.
Nice. All right, so everyone unmute yourselves really quickly. Give them a round of applause. Well done, good sirs. Any questions or comments about Mars or visiting Mars or Mars drones? Or sorry, I should say life. Mm-hmm.
Where the place you showed Euryclades, where is that?
Enceladus?
What?
What you're saying?
Yeah.
Well, Enceladus. It's a moon. It's one of Saturn's moons.
Oh, okay.
Yeah, I think Europa is also one of Saturn's moons, right?
Isn't that Jupiter's?
I think it's Jupiter's moon.
Or Jupiter's moon, yeah.
Jupiter.
Mm-hmm. Yeah, there's been a lot of attention on the moons of these gas giants because they are actually a little more terrestrial. They've got a lot of water, Europa and Enceladus in particular. And so, again, they just don't know that much, but there's possibility of liquid water underneath the surface, and that's what they get really excited about. So, yep. Yeah, and a lot of people have heard of Enceladus. Like everyone's kind of heard about Europa. They've done movies and stuff on Europa, but yeah, I think the Drake equation is always really fascinating. I have no idea how they know some of these things, like some of those variables, if you go back and look at them, are pretty nuts. But it is interesting that the number of potentially technologically, advanced civilizations, n is probably greater than one. But I think they're interested in finding anything though from bacteria to whatever. So, be honest, how many people out there do you think there's life on other planets or in other solar systems, even just bacteria? What do you think? Yeah, about half of you. I'm optimistic. I don't think it'd be very exciting to find bacteria. We want to find intelligent life forms, but or technologically advanced. But the odds of us being alone are pretty thin, actually, when you think about just how numerous the planets are and how many are in a habitable zone. Even though we did get pretty lucky here on Earth with just certain conditions coming together. So, great. All right. Any other questions or comments? All right, then we will move on to Clarence and Joseph for the moon. Clarence,
I can screen share it.
You want to? Okay, I will make you a co-host.
Sick.
All right. Okay, so everybody, you should be titling your notes "Moon and Eclipses" by Clarence and Joseph.
Okay. Sick. Can you see it?
Still loading,
Awesome.
but it's trying, I think. Yep.
Cool. Okay. Let's see if I can take it. Starting off.
Joseph, you ready?
Yep.
Alright.
Giant impact theory. So it's when a big planet symbol crashes into Earth, which rottens the Earth and makes it spin fast, leaving trails of debris behind. The trails of debris becomes the moon's orbit today. Also, some part of the debris fall back on Earth. Yep.
Okay, so basically, the moon doesn't produce its own light, but we can see it because it reflects the light of the sun. But because the Earth and the moon are constantly moving around the sun, it changes positions. And the sun can be partly blocked out, or it could by the moon, or by the Earth, or just the positioning of both. So we see different shapes, and we call these like the phases of the moon. So we start with the new moon, which is we basically just can't see anything. And then it goes into the waxing crescent, the first quarter, the waning gibbous, the full moon, or the waxing gibbous, the full moon, the waning gibbous, the third quarter, and the waning crescent. And they're shown right here in this photo that I added onto the slide.
You guys will be drawing something like that as part of a project after this as well. And sorry, can you go back one slide again, just back one?
This one?
Yeah. So looking at this, did Earth once have rings like Saturn?
I mean, at some time it kind of had, I guess you'd say a ring, but it isn't as neat as it would be in like the Saturn and stuff, just because a lot of it is debris. It would be floating around a lot more and there wouldn't be as much of it. So it wouldn't be like a distinguished ring, and it wasn't there for like a while.
Yep.
Can I explain? So since it crashed into the Earth, so it basically kind of rottens it and makes it spins in a fast rate. And that's actually not the ring. That's the trail of debris that the Earth left.
Yep.
It's shown it turned into the moon later on.
Yeah, so for some reason all that debris like clumped together, whereas I don't think that's what's happening on Saturn. It's sort of this even distribution of just dust that's all around. But yeah, pretty cool.
And so now we're going to talk about the tides. So this is kind of like an intro. So on the slides, so the tides are just the level of the ocean, or like the height of the ocean, essentially. And it's basically this one huge wave that is like kind of positions itself around Earth, and I can explain that later. So on this slide, you can see an example of a tide graph. So usually these are labeled with specific heights and times of that day, but since it kind of ranges from day to day, this is just like a blank one. And you can also see that there's a neap tide and a spring tide that I'll explain in the next one. And so below, you can see this thing called the rule of 12ths, which is basically a lot of surfers use it to kind of figure out what how high the tide is going to be. So in the first hour, we think of it as 1/12 of the full tide. The second hour is 2/12, third hour is 3/12, the fourth hour is also 3/12 of the whole thing. The fifth hour is 2/12, and the sixth hour is 1/12 again. So this is kind of how some people can read it. It's not like super specific, and it's just kind of an estimation, but this is how you can kind of predict the tides for where you are if you know a lot about them. And then so this is kind of where I'll go into detail about how the tides are created. So this photo is a really good visual on how the tides work. So as you can see, the gravitational pull from both the sun and the moon create this thing called the tidal force, which is basically just means that the pull of the ocean. So the gravity from the moon and the sun pull the ocean, making this like oval that you can see, and it's labeled both like the longer sides are the high tides and then the tops are the low tides. The sun and the moon don't always line up exactly like in this photo though, and this creates what we call neap and spring tides. And this is also this like visual helped me so much because everything else was so confusing. So as you can see, it's labeled, so the tidal bulge from the sun, or how much the gravity from each planet is pulling the tides, they're labeled down here. So the yellow one is the sun, the gray one is from the moon, and then the total is the white outline. So you can kind of see that the poles like kind of fight against each other in the way, creating either these like super big tides or like these smaller tides. So the neap tide is called the smaller tide, and the spring tide is the larger one that we can see right here. So I just thought this was a really good visual to include, just so you can kind of understand how it works a bit more, and it will really help.
Helps explain a little bit too. It's still kind of mind-boggling about why there's kind of larger tidal changes in the northern and southern hemisphere versus on the equator.
Yeah, and the problem with a lot of these like explaining tides and eclipses and the phases is because it isn't always just like this happens on this day, this time, blah blah blah, because everything's changing based on like the seasons and because of the tilt of the earth and how our orbit around the sun is an oval too, and the moon's orbit around us is also an oval. It kind of like sets everything off, and everything's like a little bit different based on like very small things. So it can be really difficult to like really show exactly like what it's talking about. So, and I'll talk about the lunar and solar eclipses. So I included visuals of what they look like in real life, and also this visual of just how it works down below. So for a lunar eclipse, the earth blocks out the sun's light, and it basically casts a shadow onto the moon. And you can see it isn't like the new moon where we can't see it, but it's more of this reddish color just because it's not directly lit up by the sun's light.
They call it a blood moon sometimes.
Yeah, it's a lot of times it's called a blood moon, and there's also blue moons. So there's 3 types of lunar eclipses. It's a total, a partial, and a penumbra. And so you can see in the visual I included, there are the 2 shadows created called the umbra and the penumbra. That's gonna mess me up. So the penumbra is this like a lot wider shadow, and it basically gets larger, and it like expands out like a cone, and it gets larger as we move away. And then the umbra is this a lot like denser pinpointed shadow. We can also see another really good visual on the next slide of the sun, and as we get farther away, it kind of pinpoints and becomes smaller. And for both of the lunar and the solar eclipses, just totality is basically when like they're completely obscured or blocked out, because a lot of these can be partial. Both the lunar and the solar eclipses have a thing called total and partial. So sometimes it could be like partly blocked out, but it wouldn't be like totally blocked out. So we have this thing called totality, which is like completely obstructed. Plus, since everything's moving, it's only totally covered for like a very little bit. So here we have a visual of the solar eclipse up in the top, and the same thing as the last slide. So in this one, it's the opposite, and the moon blocks out the sun and creates a shadow on Earth. And there's 4 types of this. There's this total, annual, partial, and hybrid. And this is, I think, is a lot. This helped me understand umbra and penumbra a lot more than the previous one. But as you can see, the penumbra is this wider, like less dense shadow that we can see, and the umbra is a very like pinpointed shadow. And these both just result in this visual up top of what we would see on a solar eclipse. And a lot of times there are like special glasses made so you can like look at the solar eclipse, which is really, really cool.
As we learned in the earlier presentation, you can see the corona, right? The outer layer, which is usually invisible. So
yeah, and that just makes sense just because we do know that the sun is larger than the moon, obviously. But like the way this lines up, it like perfectly blocks it out, except for the corona, because it's kind of this like expansion of heat and light.
actually, yeah, it's actually incredibly coincidental that the let's see if I can get this right. The sun is 400 times farther away, but it's also 400 times
100 times.
larger than the moon, and so it works out.
Yeah, that's pretty cool. And so as the both the planets, we hear about the moon slowly drifting away from Earth, probably in millions of years as it drifted more, both the lunar and the solar eclipses will change because of this. Sick.
So were the moon landings real? There's 4 evidence that the moon landing is actually real. So first is the lunar footprints on Earth. It doesn't really last like a very long time because there's all elements such as wind and the atmosphere and rains can erase it quite easily. But on the moon, it lasts longer than we think it would because there are no element that erases it. So they actually left a lot of footprints. For example, on the photo right there, there's like all those footprints left on the ground. And then second, there's over 8,000 photos that documents the trip they went to the moon. And then scientific equipments that were installed. You can see the other photo here is one, I think, for Apollo 7th. And I think they left it there actually. So the last one I think is the most interesting one is samples that we brought back and the knowledge that we gain about the lunar geology. Astronauts brought back orange soils and discovered they are volcanic glass. So I think that was very interesting. So we have evidence that like from like the moon that, yeah.
Well, it's a lot of evidence that the moon was once part of Earth, right? That the composition of the moon was definitely had Earth elements.
Yeah. Oh, so the festivals for like about moon is just passed. How many days ago? 3 days ago, the Mid-Autumns. So Mid-Autumn Festival is a traditional festival in China. It's during the time they'll like after dinner they'll all watch the moon together as a family. So people think it's a time for reunion because like also the moon is like a circle in China. It also means like how like families all gather up during that time. So after like during the Mid-Autumn Festival, people for sure eats mooncakes, and then yep, it was
Did you have some mooncakes, Joseph?
yep, I did. What happens if the moon disappeared? So without the moon, the Earth will orbit faster. The tides will fall and the seasons will change. Our days will be shorter. It's gonna from instead of 24 hours, it'll shorten to 6 to 12 hours. Possibly that there will be 1,000 days in a year.
That's kind of interesting that it's slowing down the Earth's rotation somehow. All right, cool.
And then successful moon landings. It's just a bar graph that I made. So it's Surveyor 1 at June 1966, Surveyor 3 April 1967, Surveyor 5 September 1960.
Those were all just satellites, right? Those weren't manned. They're surveyors, right?
Yeah, those were the and the Apollos. And then for the surveyors, there's like the pictures here for Surveyor 1 that we took like foot what is it called? footage of. Yep.
Mm-hmm.
And then July 1971, Apollo 15 is one of the picture of the astronauts on the moon.
Yeah, I think that's something. Hey, great. Yeah, a lot of people, everyone's heard of like the Apollo 11 and Apollo 12 missions with Neil Armstrong and Buzz Aldrin, but yeah, people don't realize there were 5 more with astronauts making frequent moonwalks. So yeah,
Thank you.
Sick.
well done. All right, let's everyone unmute yourselves, please. Round of applause. Okay, any questions or comments about the moon and eclipses? Surfers in the group, did you know anything about that rule of 12ths? I didn't know anything about that. Ryder, Thomas, no, any of you guys? Sounds interesting though. Like I do know that, I don't know from a surfer standpoint, I just know from like lobstermen in Maine who, these are guys who live on the ocean and fish. They're like hyper aware of the tide. Like you can ask them and they know what the tide's doing. Like they just have it all because they've lived their whole lives like that. And it's kind of similar that they know when there's going to be a high or a low. And so, but I think they use some of that too about they think back to when they saw the ocean last and then do the math from there. It's kind of interesting. Joseph, I liked your cultural reference. The other thing I think is a lot of religions. If you look at religions, there's a lot of moon stuff, in particular Islam. So Muslims are very attentive to the moon. If you look at a mosque, there's often a crescent moon as part of the symbol. And the month of Ramadan, which is when they fast whenever the sun is up, it's a full moon cycle. So it's 1 month, but really most like really dedicated Muslims will, once the new moon is formed, then they'll stop and they won't pick up eating again until they see the moon again. They've gone through a full cycle. So kind of interesting. How many people here have seen a solar eclipse, like the sun blotted out by the moon? Quite a few of you. Very cool. Something I've always wanted to see. There are actually a couple happening I think within the next couple of years in the US. So this is kind of like, if you're in America, this is your time to travel to like the Midwest and stuff to go see that. I know some people who are obsessed with this kind of stuff and they literally make travel plans. They like plan their lives around when they're going to get to see the next solar eclipse. If anyone had Mr. Provo last year, he's a very enthusiastic person with, he's always tracking those down. So great. Okay, no other questions or comments? All right, well, thank you very much to those groups that presented. Please make sure that you submit photos of your notes to those assignments, which I've created. It's topic number 5, topic number 6. For those groups who presented, please make sure you are submitting your test questions. I only need 1 multiple choice and 1 free response per group. On the bottom of the tasks to complete list, you can see a link to the Google form. It's also on the discussion board where you posted your little share options there. So, all right, how are we doing on time here? All right, we've got 10 minutes. So I'm going to use the last 10 minutes to give you a head start on the homework. The homework is 3 things based on the moon. The first, and you can see these on the bottom of the tasks to complete list. This is task 7, task 8, and task 9. For number 7, drawing the phases of the moon, very similar to that image that Clarence showed us. I'm going to have you just on a piece of paper, use your compass to make the circles. You'll make the sun and the earth and 8 circles around it to represent the 8 phases of the moon, and then you'll shade them in and name them. There's 2 videos that are going to guide you through that. There's a Canvas discussion board where I want to do a quick claim evidence reasoning, just short thing about the moon landings and whether or not you think they were faked and what evidence you have to back that up. And again, your claim doesn't necessarily have to reflect your true belief. If you want to like look up what evidence is there, what are people saying that points towards them being faked. And then there's a short flip grid assignment where you're basically going to imitate the moon transition, where you need to get into a dark room with a single source of light. Could be a flashlight, could be another phone, could be a bare bulb, and you need to hold something spherical. It could be an apple or whatever, a baseball, but you're going to film from your face outwards, right? So hold your phone up in front of your face and then just do the rotation around, and you'll see how the light changes, and you can actually see the phases of the moon just on that object that you're holding. So so I'll give you the next I'll time for about 9 minutes or so. We'll come back together for the last minute of class, but get going on that first drawing assignment, and then we'll come back together to reflect. So let me know if you need help. If you have questions, I'll be here listening. Go for it.